Hello and welcome again to my Physical Science Online Labs video series. In today's video I wanted to do a brief walkthrough of the Solubility Lab. In the Solubility Lab, the goal is to measure the solubility of sugar, that is C12H22O11, and salt, NaCl, sodium chloride, each individually in water. And to do this as a function of water temperature. So the units for this experiment are going to be how many grams of the sugar or of the salt can you dissolve per kilogram of water. Or we could do how many kilograms of the sugar or salt per kilogram of water. And in fact, I believe the textbook does how many grams per 100 grams of water. Being a physicist, I actually prefer kilograms per kilogram, but if you want to be able to compare the curve that you get for sugar with the curve that's in your textbook, you might want to do grams per 100 grams of sugar per 100 grams of water, or grams of salt per 100 grams of water. We're doing this as a function also of temperature, so we're going in 5-degree increments of the water. So the equipment that you're going to need for this lab includes, first and foremost, some simple water. This is actually distilled water. This label right here actually says distilled. And that's what you're looking for. You can buy a container of this stuff, like a 1-gallon jug, for less than $1 at most grocery stores. You may end up wanting to get a few gallons of it by the time this whole experiment is over and done with, just to be on the safe side. Second, you need your sugar. So just some simple imperial cane white sugar, and you need your salt, NaCl, sodium chloride. And with both the sugar and the salt, with the salt, you got to first of all watch out when you're buying it from the store. Make sure that you're getting sodium chloride, not Epsom salt, not other types of potassium salts, not iodized table salt. You just want plain NaCl. The second thing to look out for is that they sell salt that's like this, the extra coarse salt. It looks kind of like a bunch of small rocks. Actually, what you want is this nice fine granular salt. So here I'm pouring the salt granules in. So that's about what you want for that. Next, you're going to want a thermometer, because you got to know what temperature the water's at. And then you need some container for the water to go in. So here's my container. I've got 700 milliliters of water in this container. Your directions say 2 liters worth. That's just a guideline. You can use less if you'd like, or more if you'd like. The goal is to not have too much of it evaporate when you go to the higher temperatures. And also, as you get to smaller amounts of water, you also get to less total sugar or less total salt that you need before you hit saturation, which is fine. And in fact, the way that I would do this experiment is to first of all get an estimate as to saturation level using very coarse measurements, and then do a finer measurement to get the actual solubility. Next, you need something to stir with. I've got this glass stir rod, courtesy of the chemistry department here. You can also use, if you have a fancy setup, you might have like one of these little magnetic stir rods, which you can not really see very well. There it is in this water. And last but not least, you need like a stove. So this thing right here serves as stove and stirrer. So there's the stir function, here's the stove function. That's just so that you can get a desired temperature. So you can go up in increments of 5 degrees or whatever. So as I was saying, you should measure the water temperature. Should be 10 degrees when you start out. For demo purposes, I don't have it at 10 degrees. Actually, it's rather close to 30 degrees right now. But you're going to want to start at 10 degrees Celsius, so refrigerate it. And last but not least, you need some way of measuring the amount of sugar or salt that you add. You actually want to know the answer in grams, but you can use something like this, a little beaker. You can add 10 milliliters at a time, for example, and then figure out how much mass 10 milliliters has, or maybe figure out how much 40 has and divide by 4 to reduce the amount of error in this experiment. So what you do is you then add your salt or your sugar in the increment size that you've chosen. So I've chosen this 10 milliliter increment size and just simply add to the water. A nice little cloud like that, and stir, stir, stir until it all dissolves. Because I know how much water is in here and the temperature and the solubility of salt, I know that it's going to take maybe a couple hundred grams of salt before I saturate this particular water solution. So that's going to take quite a few of these containers worth of salt being added. The way that you should do it really is pick some coarse amount to add. Let's say 10 grams at a time. You add your 10 grams, you stir until it's all dissolved. Then you add another 10 or even 20. 20 at a time is fine. And what will happen is, for example, maybe you have enough water and at the right temperature that you should be able to dissolve 311 grams, let's say. Well, if you're going 20 grams at a time, then once you've added your once you've added 300 grams, you should still get it to all dissolve. But once you add 320, you should have some salt left over that has not dissolved. And that leftover non-dissolved salt tells you that it's now saturated. So then I would actually throw out that water, pour in an equal amount of water, make sure it's still at 10 degrees, add salt until you get to 300 grams, at which point no salt should be left undissolved. And then once you've done that, then switch to a smaller increment size, maybe 1 gram at a time, until you can no longer dissolve all the salt that's been added. By doing that, you know that it's going to be over 300 anyway. So you add another 1 gram, it all dissolves. You add another 1 gram, it all dissolves. You add another 1 gram, it all dissolves. And finally, you get to 310 or 311 grams. You add that 1 extra gram, and suddenly it's not all dissolving. You've got a pretty good estimate at that point. Maybe you end up getting 309 or 310, 311, 312, somewhere in there. It's expected to be 311. So if you're off by 3 grams, that's like a 1% error. If you're doing an increment sizes of 20, then all you know is that somewhere between 300 and 320 grams, you hit your solubility maximum. You hit saturation, in other words. So What it ends up looking like, by the way, when finally it's been saturated, is that there is some leftover salt that's in the bottom of the container. So you can see some salt that's still not been dissolved here, and that's true even if I continue stirring at very, very high speed. There still ends up being some of this salt left over at the bottom. That means that I've hit the saturation limit. Okay, so then I know that I can, if I add more salt, it will simply not dissolve. And what basically ends up happening is, as I add more and more salt, see, I'm stirring very, very rapidly here. Better turn down the stir rate, or it's going to go wild. But basically, what ends up happening is you end up with a saturated solution so that there's still this leftover salt in the bottom. You write down how much you've added. Now you've got the saturation level. Now you add another 5 degrees of temperature by heating the water, and then you add in increments of 1 gram or 2 grams or whatever small increment size you can get away with, and write that down for the new temperature, and so on up to 60 degrees. And then you repeat this for both sugar and for salt. And that's basically the experiment in a nutshell. Then you can graph temperature versus solubility. One of these two should duplicate a curve that's straight out of your textbook so you can compare it. And that's the lab. So I hope you find this video helpful, and thanks for watching.